Hello everyone. I hope you are enjoying spring break, and I guess we will not see you on campus for a couple more weeks. So the way I decided to do the lecture, we're supposed to teach you online. So I'm gonna tape my lectures. Each lecture will be taped into two videos. Each video will be like 20 minutes, and I will upload them to YouTube, and I will email you the link, and I expect you to watch them. You should be ready for lectures on Monday, Wednesday, and Friday. I will hold kind office hours, so I expect you to email me questions. I will work on them and send more videos, again similar to the lecture. So email me your questions about the homework problems, about anything. I don't know how I am going to do the testing, quizzes, and so forth for now. I think what I have decided to do, if you return to campus, I'm gonna reopen skill test 2. We're gonna forget about skill test 3. So basically this is what we are going to do. Today we're gonna continue with a series. I am going to talk about alternating series test, and that is section 1.6. So I'm gonna skip 1.5, do 1.6 first. I think it's a better sequence that way, because you will need 1.6 for 1.5. So this, I don't know why the book does it this way. So this is what we are going to do. So far, is this too far, Nancy, maybe? So far, we have done series testing. We have done the partial sum, so we're gonna call it a PS2. We've done the divergence test. We're gonna call it DT. Remember, this says nothing about the convergence. Either it diverges or you cannot say anything. Okay, so third one, we did the geometric series. Fourth, we did the integral test. Geometric series, we call it a GS. Integral test, we call it IT. 5, we called it the comparison test. We're gonna call it CT. And then 6, we did the limit comparison test. So it's LCT. Okay, so this is how many tests we've done so far. I have a surprise for you. Come here, Lily. Come here. I think the class wanna see you. Come here. Come. And here is Lily. You remember my dog? Where is she? Lily, stay away from me. This is Lily. See? Do you see Lily? Okay, Lily, I'm talking to my class. They all ask about you. All right. Okay, Lily. Oh, I don't see anything. All right. Sorry. Okay, so this is how many tests we did so far. I know. I think I may need someone to hold the phone for me. It will be easier. Okay. So today, this is what we did. So we're gonna talk about section 1.6 called alternating series test. That's called the alternating series test. I hope you can see. All right, well, alternating means sign-wise. So this series is gonna go take negative term, positive term, negative term, positive term. Okay, so this is what it means. All right, so let's say definition. Okay, an alternating series is of the form n equal 1 to infinity minus 1. You could go from minus 1 or you could go from plus 1. an, okay, where the an are bigger or equal to 0. So basically, this one, n equal 1 to infinity minus 1 to the n, say minus 1 an, is for n equal 1, this is 1. So will be a1 minus a2 plus a3 minus a4 plus a5, and you will see how it goes. So this is, we call it alternating series. For example, I can take a look at n equal 1 to infinity minus 1 n plus 1 over n. For n equal 1, this will be 1 over n, 1 over 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 and so forth. Okay? So this is what it is. So this is what we call an alternating series. So now we need to make sure that the series converge or diverge and so forth. Okay? So that brings us to the next thing here. So this is the alternating series. All right? Okay. Now my wife is sitting in the other room listening to me, so. Hi, Lily. Lily, where are you? Come here. Come here. Come. Come. Yeah, you're a good doggy. You wanna jump? Hey, hey, see? They can see you. Yeah, bye. All right. Okay. So we have the alternating series test now. Okay. All right. So let an be positive for all n. Okay. All right. If, so we have, if an plus 1 less or equal to an for all n bigger or equal to n, this is for some number n. I mean, it could be 1, it could be 2, as long as this number is finite. That's called 1. And 2, the limit as n goes to infinity of an equals 0, then the alternating series n equal 1 to infinity minus n minus 1 an converges. Okay? So that is the statement of the test. All right? So let me go and I will go over the proof a little bit, but let me go do a couple examples. So we need two things, actually three things. All the an has to be positive. All the terms has to be positive. So what this means is this one here mean an is decreasing. Okay? So that means an is decreasing. All right? And then we need the lim of an goes to 0. Then the alternating series n equal 1 to infinity minus 1 to the n minus 1 an does converge. All right, so this is where we are for now. Okay? So let's take a look at a couple examples. Ready? Move. All right. So let's take a look at example 1, n equal 1 to infinity minus 1 n minus 1 over n. So what do you think? Well, no test will work for this one because we haven't done anything like it before. So let's apply the convergence. So you notice this is n equal 1 to infinity minus 1 n minus 1 times 1 over n. So that number is your an. Okay? So that is our an. All right. So let's see. So an is 1 over n, and that is positive. Correct? For all n bigger or equal to 1. Also, an equal 1 over n is decreasing for all n bigger or equal to 1. So that one is our number n. All right? And finally, the lim as n goes to infinity of an is the lim as n, approaches infinity of 1 over n, and that is 0. So all the hypotheses of the alternating series test is satisfied, and therefore by the ALT alternating series test, AST, the infinite sum converge. So by the alternating series test, AST, remember, stand for all alternating series test, the series converges. Okay? All right. So this is what we know so far. So what do you think? You want to do an example yourselves? All right, so let's take a look at here another example. Here is another example. It's n equal 1 to infinity minus 1 to the n minus 1 times 2n over 4n squared minus 3. Okay, so we're gonna decide whether the series converge or diverge. Okay? All right. So what do you think? So that's an alternating series. So here, our an is 2n over 4n squared minus 3. Okay? Now, you will see that this series is positive for all n bigger or equal to 1. It's clear. Because 4n squared minus 3 is positive for n bigger or equal to 1, and that's it. This is the only term you need to worry about. Now we need to show that the series is decreasing. So let's take a look at f of x is 2x over 4x squared minus 3. Okay? Then, of course, in Calc 1, we taught you that in stuff like that, you take, you look at the derivative. So what is f prime of x? It's the derivative of the top times the bottom will be 2 times 4x squared minus 3 minus 2x times 8x over 4x squared minus 3 quantity squared. All right, let's simplify this, otherwise we won't be able to say anything about it. If I simplify this, this will be 8x squared. So I'm going to have 8x squared minus 6 minus 16x squared over 4x squared minus 3 squared. I'm not going to worry about the bottom because the bottom is always positive. Okay, so this is minus 6 plus 8x squared over 4x squared minus 3 squared, and that is less than 0 for all x. Therefore, an is decreasing, and this is decreasing for all n bigger or equal to 1. Okay? All right, so there's one thing left to verify. So what is it? Can anybody guess? Come on, let me hear it. Well, I guess I can't hear it. So the third thing is we need to show that the limit as n goes to infinity of an is 0. And that will be 2n over 4n squared minus 3. And that is at infinity, that behaves like 2 over 4n, and that is equal to 0 at infinity. So, what do you think the series does then? Okay? So, by the alternating series test, the series converges. Okay? That's pretty good. So, we got that out of the way. So, I'm going to ask you to do, so please do practice. Let's say n equal 1 to infinity minus to the n over, what are we gonna do? N squared plus 1, okay? So let's try this, and another one, n equal 1 to infinity minus 1 to the n, okay? And let's go from minus 1, that's all right. And I'm going to have square root of n over square root of n plus 1. Okay? So try those and see what you can get. So I'm going to stop the first video here. I will do another one in a few minutes. So what I want you to do, I want you to watch the video, give me some feedback about it. I really want you to have listened to both videos by Monday, by the end of Monday, so we can continue with Tuesday, problem session, and so forth. I'm gonna ask, I did ask your TA to hold office hours on Zoom, so I will remind her again and how to do it. So for Zoom, you will receive an invitation link, and then you log in and ask questions. And again, as I said at the beginning of the video, I'm gonna solicit questions from you after I assign homework. You go over them. If you have any questions about the lecture or the exercises, you send me an email which problem to do. And I'm gonna say on Thursday, I will have another video related to homework problems. All right, I will be back. So each lecture will be 2 videos. Lecture 1, the videos will be labeled 1A, 1B. Lecture 2, which is on Wednesday, will be labeled 2A, 2B. And this is the way we're gonna do it as we progress. All right, see you in a little bit. Bye, thank you.